Welcome back to KSET previous year question and solution classes. So today I will discuss a condensed matter physics or solid state physics or material science part questions. Okay. So there will be a 10 questions from these subjects. So let's see, the question is like this: the value of flux on in a superconductor in SI unit. So they asked the flux in terms of SI unit. So if you know the SI unit of flux, you can easily guess from these 4 options. So what is the SI unit of flux? So see, this all the 4 SI units are different. So we can easily guess. Okay. So we know that flux. So I am going to write flux in terms of magnetic field. So flux is equal to integration of B ds, which is equal to, so what is the magnetic field, the SI unit of magnetic field? Tesla. And what is ds? ds is area element. So what is the SI unit of area element? Meter square. So Tesla meter square is the SI unit. So in the given options, is there Tesla meter square? C, option number C. And the numerical method, the numerical value you can also calculate by using the formula flux phi is equal to h by 2e, which is equal to 6.626 into 10 to the power of minus 34 divided by 2 into 1.6 into 10 to the power of minus 19 coulomb. If you calculate this, flux is equal to 2.0678 into 10 to the power of minus 15 Weber, you will get. So this is the correct option. So this is the question number 57. Again the question is based on superconductivity. In the BCS theory means Borden, Cooper and Schrieffer. These are the 3 scientists. In the honor of these scientists, you can call it as a BCS theory. Superconductivity, the superconducting state formed from. So how the superconducting state is formed from? According to these scientists, so because of bosons, fermions, protons and electrons. That means if 2 pairs of electrons are formed, so then what is the resultant of the system? So let us consider this is the system. In the system, if we have 2 electrons like this, we know that electrons is a spin of fermions. Okay, spin 1 by 2 fermions, electrons, and bosons are integral spin particles, integral spin. So that is 0, 1, 2, 3 like that. It is an integer number of spins. And these fermions and protons and electrons, these protons and electrons belongs to fermions. Fermions may be spin of fermions or spin 3 by 2 fermions of integral spin. So like this, n by 2 spin, like 1 by 2 or 3 by 2 or 5 by 2, so on. So these are all fermions. If the spin is like this, so then these are all bosons. Let's see, if suppose 2 electrons in a system, the 2 electrons, if they are in opposite spin, one is plus 1 by 2, another one is minus 1 by 2. So then the total answer is 0. If in the system, if the electrons is plus 1 by 2 and plus 1 by 2, so then it is 1. So the resultant is 0 and 1. If the system has 0 and 1 spin, if there is a 0 spin state or 1 spin state, so then these are bosons, because bosons are integral spin. So answer is option A. So this is the question number 59. The schematic arrangement shown in the figure. So this is the figure given. is for measuring one of the followings. So, in this diagram, here we have three temperatures, temperature 1, temperature 2 and temperature T0. And here we used two different metals, one is metal A, another one is metal B. Okay? And this effect is Joule effect, Thomson effect, Peltier effect and seebeck effect. Seebeck effect. So, here if suppose see, if voltmeter is connected in the junction of different temperature, that indicates that if the temperature is changing, if in the two metals, if we use two different types of metals, in these two different types of metals, if the temperature is changing in the junction, because of this changing temperature, an electrical current or electric current is induced. Okay. So, and there because of the changing potential difference between the two junctions, due to this changing temperature, a potential difference is created. Okay. This effect is called seebeck effect. This effect is seebeck effect. And Peltier effect means, so is reverse of seebeck effect. That means because of change in electric potential, due to some chemical change, because of change in electric potential between the two junctions, a thermal energy is produced, and that effect is called Peltier effect. And this Joule effect and Thomson effect is this is also a effect which related to thermodynamics. Okay, or it is also depends on temperature and heat process. So, here amount of heat is observed. Okay, okay, that is not our point of view. In the next class, we will discuss in detail about these concepts, but here it is seebeck effect. For this question, the answer is seebeck effect. If there, because of change in temperature, if electric and because of changing temperature and electric potential difference is created, and due to this electric potential difference, an electric current is created or electrical energy is created, and that effect is called seebeck effect. Okay. Superfluidity is a state of matter in which the matter behaves like a fluid with infinite viscosity, zero viscosity, high viscosity and low viscosity. So, superfluidity means it has zero viscosity. Okay. So, this is the answer. So, this is the question number 6, which based on Hall effect. According to Lorentz model, the Hall coefficient RH, or suffix H actually, that is, of metals is given by. So, these are the four options given, A, B, C and D. Okay. So, the Hall field is an electric field developed across two faces of a conductor in the direction of J cross B when a current, so when a current J, so this is the current density J, flows across a magnetic field B. See, that means an Hall effect or Hall field is a new field set up in a conductor or any specimen, okay, or metal specimen, when this is placed in an external magnetic field, and this specimen of the two faces is also applied with some electric charge, some electric field, or let us apply electric potential. Due to this electric field, a flow of current will be there. So, in our specimen, see, we know that if a charge, any free charge placed in an external electromagnetic field, a Lorentz force is created. Okay. So for example, if this is a free charge placed in an external electromagnetic field, a Lorentz force is created. F is equal to Q into V cross B plus E. Okay. And so here also, like here, it is a number of free electrons will be there in this specimen, and this specimen is placed in electromagnetic field. So there definitely there will be a Lorentz force. So now, and see, if this is the magnetic field and this is the current. Now if this specimen is placed in magnetic field, if current is in x axis and magnetic field is in z axis, in J cross B, so J is x axis and cross B z axis. Okay. So then the resultant field, all field developed in the specimen is in y direction. So when there is a potential difference is applied between the two phases and this specimen is placed in an external magnetic field, a new effect RH is equal to minus 1 by Ne for an electron. So this field is opposes the Lorentz force, which balances the Lorentz force in the specimen, and this effect is called Hall effect. If for an electron it is 1 minus, we will use minus 1 by Ne. For a proton we will use plus 1 by E. Okay. Actually in this specimen, see for example this is the specimen, a positive charges is accumulated one phase and negative charges is accumulated in another phase. A new electric field, a transverse electric field is created. If this is in current, this is a current direction and this is a magnetic field direction Bz. This transverse electric field is created. Okay. And this effect is called Hall effect. This transverse electric field is created across the two phases of a conductor in the direction of J cross B if there is a current in the specimen and magnetic field in z axis. Okay. So this is called Hall effect, and the answer is option number C. So this is the question. Again it is also a superconductor problem. The frequency of a AC current produced when a DC voltage of 5 microvolt is applied across Josephson junction is. So here they asked frequency. We know that the expression frequency F is equal to voltage V by flux. Okay. So what is flux? Flux is equal to 1 by 2 into E, sorry, H by 2E. Okay. Next. So therefore, if you substitute these values, we will get 2.0678 into 10 to the power of minus 15. And therefore, F is equal to, so what is V? V they are given. So 5 into 10 to the power of minus 6. So what is flux? 2.0678 into 10 to the power of minus 15. So after solve this, we will get the answer 2.41 gigahertz. So the nearest neighbor distance to R in a body centered cubic BCC is, see, BCC means body centered cubic lattice. We know that if suppose these are all the position of a lattice points, body center means in the center of this cube, this is the center. Okay. If we take a cubic structure in the center, exactly center, but this center is not touched all the spaces, in that position there is one more lattice is there. and this lattice to this distance and this distance, this distance, this distance are nearest distance. So that is, so nearest neighbor distance for this BCC is 8. 8 corners of the atoms are in the same distance. So now we are going to calculate from this body center what is this distance, or this distance, or this one. Okay. So we know that, so the schematic diagram of that one, if suppose this is body center lattice, from this is R and this is R, so this is 2R, and this is R and this is R, this lattice and this lattice contribution to this BCC, this is R and this is R. If you take a schematic diagram like this, this is the body center atom and this position. So for simplification, I am considering this part and this part and this part. Okay. So this part is body diagonal to these two surfaces. Okay. So that is these two surfaces, and we know this is A, this is A, and obviously this is 2A. Sorry, root 2A. Why? Because by Pythagoras theorem, if suppose, see, if this is A, this is A, this is root 2A. AC square is equal to AB square plus BC square. So therefore this is root 2A. Now, so therefore this is root 2A, and this distance, now let us consider if this is A and this is B and this is C. AC square is equal to AB square plus BC square, and what is AB square? Root 2A whole square plus what is BC square? A square, and what is AC square? 4R whole square. So therefore 4R whole square is equal to 2A square plus A square. So answer is 3A square. Okay. So 4R square is equal to 3A square, and this can be written as 4R whole square. So 2R into C, and therefore we can also write this as 4R is equal to root 3A square, and therefore root 3A, and 2R is equal to root 3 by 2 into A. This 4 can be written as 2 into 2. So therefore 2R is equal to root 3 by 2 into A. Option C is correct. So this is question number 64. A free electron is placed in a magnetic field of strength 1 Tesla. The strength of the magnetic field is 1 Tesla. The resonance frequency. So we know that when an electron is placed in a magnetic field, it start rotating if the magnetic field is uniform, and this frequency of rotation we have to calculate, and the energy expression for this is E is equal to magnetic moment created by this rotation of electron mu into gyromagnetic ratio G and magnetic field B, and we know that E is equal to h nu. H nu is equal to mu G B. Therefore nu is equal to mu G B by H. So mu is given 9.274 into 10 to the power of minus 24, and what is G? Gyromagnetic ratio 2.0023, and what is magnetic field? 1 Tesla divided by what is H? 6.626 into 10 to the power of minus 34. So after substituting all these constants and calculating, we will get 28.02 gigahertz. So this is the answer. Okay. Okay, in the next part we will discuss some more problems on this condensed matter physics. So this is the part 2013 year question paper, and in the next video I will discuss 2014 paper, and it's a very easy questions, and we can generally logically answer for this part. Okay, we will discuss in the next video.